Hello and welcome back to yet another video in the FEAP discussion series. Today we are going to start a new topic of discussion. So far we have been talking about theory and theory. Today we are going to start talking about the software part, the implementation of whatever theory we have seen so far in the various parts of the papers. So this is the GitHub repository main page of FEAP repository, and here we have the entire source code of FEAP, which is modified to include the WAM aspect of it also. So that's how it is named, FEAP WAM. And we have made around 13 commits. So first of all, before going into the source code, let us look at this repository and how to make best use of it, and how to make use of Git actually, which is a main version control system we have right now. So let us look into it. So I will touch upon some basic terminology and some important terms which are utilized in Git framework. So there is a concept of branch. First of all, we can have multiple branches to our source code. To explain it briefly, let us consider that one of us as a software developer wants to start a new module of the source code. So they can create a new branch which is different from the master or stem branch, and they work on it and then later on merge their work with the main source code. So that is how the usual workflows happen, and it helps in collaborative kind of work. So we can easily create a branch, and we can switch to different branches by using git branch command. And actually this is little difficult sometimes for beginners, because we may not easily grasp the idea of switching branches and merging branches. So in the starting, maybe all of us will continue working with just the master branch, and as we become more comfortable with using git and pulling the codes, then we can maybe start using the branches. So till then we'll have to work only one at a time in that format. So whenever one person is working, we will others will not work, and whenever we start making some changes in the code, we'll just make a pull. Means we download the whole source code or whatever changes have happened, that will have fresh copy of that, and then we make the changes and push it. So then the next person can proceed in the same way. So that is how we will work, and as we become more comfortable, then we can start using the branches also. So that is the concept of branches. Right now we have just one branch, which is the master branch. Then there is a concept of commits. So whenever we make some change, we commit that this change has happened, and we give it a title like we have given over here. So that we know in summary this is the work which has happened in this particular change, and we can access to those commits, like whatever state that software was at that time and that commit was made, we can, whenever we want, we can switch to that state. So that is the main advantage of using Git, because we can switch back. Suppose we have made some wrong move, we can switch back. Okay, so there is no worries. Okay, so let's say I want to go to this commit which with this heading, so I can just click on this button and I will be taken to that page. So now the code is at this commit, and I if I go inside this folder, so I'll be able to access those files. So that is how we work in this software. So a few commands I'll just list down, which should be very familiar and it will become a routine job to use those commands. So one is git add dot, git stage, git status, git push, git commit minus m, and then the message in within the double quotes, git commit minus m, double strings, double quotes, then git push. These are all related to editing and then pushing the code to the repository. Then for pulling the code from the repository, git pull, and for the first time when you are doing, git clone, and for all the regular um, pulls it will be git pull. Okay, and yeah, mostly these are the commands. Git diff is also there if you want to compare two files, git diff file 1 file 2, git stage, and git add is for adding the files for making the commit. So git add, all the red color files will become green. Okay, and when the files are all green, that means they are all ready to be committed. When their files are red, that means the changes have happened in those files. So we have to write the command git add to add them for being able, for making them able to be committed. Okay, so like that. So now first time if you are coming to this repository, you can, if you are not a frequent user, frequent developer, then you can just download the zip file, and from here you can access the current version of the code. Or else if you are a frequent user, there are basically three ways as listed over here: HTTPS protocol, SSH protocol, and there is command line interface for the GitHub. So if you are very frequent user, then SSH would be more easier for you, because in HTTPS you need the credentials also every time when you are accessing, whereas in SSH you can provide your computer's public key, and that way you can access without providing every time your credentials. So you can just go to settings over here, and if you go to SSH and GPG keys option, here you can see I have provided my computer's key, and same way you can also generate a new SSH key also. So if you just click on this, you just give the title of your computer which from which you will be accessing. If you are changing the computer, then you will have to again provide the SSH keys for that computer. So here provide a title, and here you have to just paste the public key which, and the file which ends with .pub. When you generate your the keys for your computer, there is a command, git command, you can search online for generating that key. So you have to just paste from the contents of that file, you have to paste over here, and then that SSH key is added, and your computer is ready to be able to access the Git repository online, and you can simply clone the software in your system as it is the state in which it is right now. Okay, so this is how it is. So enough we have talked now about the Git aspects. Now let us go into the software details. Okay, so here we can see the main folder, the main directory of the software is termed as FEAP. We'll go inside this. By the way, we have put one git ignore file, so it does not track all these files which are listed over here, like .o files, .a files, which are compiled files, object files, and other HTML and LaTeX based files, and all the text files. And so these files are not tracked. So if you make certain changes, it will not track those. Okay, now let us go inside this FEAP folder. So here we have a few folders and files. So this Python patch folder is something not uh, it didn't came with FEAP. It's something which we have written as a patch, Python based patch for some functionality. This we'll talk about later. And these are some license files of the software and receipt, payment receipts, etc. And let us go inside this var85. So we are working inside this var85 folder, not var85.2. This is very much like a copy of this for same folder. It came like this only. Don't know the reason why it is so, but these two both are very similar. So let us go inside this one. So here you can see the entire structure of this FEAP software. There are different functionalities and different workloads associated with different folders. Like we have element folder, so here we have different kinds of elements: frame element, shell element, solid 3D, 1D, 2D elements, thermal, torsion, wrinkler, okay, acoustic. Different elements are there, and there is a make file, okay, and there is a main folder, and contact based problems, plot folder, user folder. So here all the user defined elements, user in based input file is there, okay, and we have a folder program. Here the lots of functions or many important files which are like miscellaneous, they are all included in this folder. And yeah, then the most important file over here is makefile and makefile.in. So this is where, from where the program starts basically. So make is a very important command in Linux, which helps in building up the software. So in the installation, if you have seen the installation video, and the first step when installing is the installation of the make in Linux. So we have to first install make, and after doing that only we can execute these commands. So in order to install the software, we either do make install or make archive or make FEAP. Make FEAP usually we do. So it includes archiving. So all these steps are done, and when we have to do recompiling, so or sometimes we need to clean up, so we do make clean. Okay, so this is what we do, and then we again do make install or make FEAP. So like that we compile the software or install the software, and these are all the commands which are executed. So you can see inside every folder we have a make file, and it is executed. That means after doing cd to that folder, it does make archive again. So there is a make file over there also, you can see in all these folders. So this is the main make file which is inside main folder, and there is a makefile.in. Here lots of options are set. We can just see a few of the important ones, like we have enabled finclude here, okay, and these are the options which we were suggested in the installation video, and cinclude is done here. And so this is related to my Mac OS based X11 server we have included, and for Linux it might be different, for Windows it might be different. And the compiler we have enabled as G Fortran GCC compiler, not the Intel compiler. And yeah, this is also an important option, FF opt flag or CC opt flag. We have put it as 0, so just take note of this. Rest of the options are all commented. Okay, yeah, LD options are also described over here, and LD options FE2. Yeah, so these are the contents of makefile.in. So this is the very first thing which we do as part of the installation process, and this is just for once, not again and again. So let's say we have done this file makefile.in, and makefile is all configured well. So then we can do make FEAP or make install commands we can do to compile the software, and then we can run it. So now let us go into the structure of this software. So first let us check out this main folder. So if you go inside this main folder, we can see there is an inputs folder. So this is the folder from where the input file is obtained within the software. So when we got this software, there is a inputs, two kinds of inputs folder came along with it. These are these two. So these contain some ready-made input files for different cases, and you can of course go into this. Whereas whatever inputs file we made, we make a separate folder for that, inputs underscore made. So these are the input files which we have created for our own testing and solving. So if you check out one of the files, and this is the structure. So they have defined very well properly and the structure of the input file. So in the starting you have to provide some parameters, then the kind of problem you are going to solve, is a shell problem or a beam problem, or it is a finite deformation, or it is a small deformation problem. Then the kind of material you have, elastic, linear elastic, non-linear, Neo-Hokian, and thickness and all you specify. Okay, then material models can be specified as a model set number, so that also can be done. Then there are block commands to generate the nodes, or you can say list of nodes. Okay, and there are some commands to do that. You don't always need to just write the all the nodes one by one, you can auto generate them. So there are commands which are listed in the user's manual in chapter 5. And then according to the above numbers, you can specify the boundary conditions, force boundary conditions, etc. So in this part, the first half, you can just simply specify the problem. Okay, so this is the first part of the input file, and then you specify the solver related details. So there are two loops you can see. One is the outer loop, time step loop, and the inner one is related to the iteration. So here you specify the tangent modulus you have to take with form residual, then solve command is there. Then you have to update the iteration, like that it will be happening. And dt, time step, you specify number of iterations you apply by in the loop command. And then you have to specify what output you want, post processing related commands. So you want to display all the displacements in the output file, and plots, etc. you have to specify. And if you want this, you can keep it as interactive. So through the terminal you can keep interacting with the output files. And if you don't write this command, then it will not be interactive. It will be just dumping the output files in the final folder. So within the same folder, we get the output files also. So right now we don't have any output files because we have put those in the git ignore. So those are not tracked. Only the input files are tracked. So this is the format of the input files. So it collects the input information. And yeah, actually it will be good time to show you the user input file also. So these are all input files related to FEAP based inputs. One more thing I forgot to show you, within the inputs file, if we go, let us look at I flat plate 4. So you can see here we have provided lot of custom based input. So this input was not a part of standard FEAP input, but we have provided from other side, from our side. So we have provided an interface for providing this as an input. This is related to the WAM. So any WAM model we are going to combine. So for that we will require some different kinds of inputs. So our input format might change. So there is a user input file, it is called as umat i1. So now we'll go and check out that file. How is the input format decided, means where is the file located, so that whenever you are creating any WAM model of your own, you can basically write the umat in file, umat in file. So let us go to Oops. Yeah, so this is the file u mat I1. Okay, so here we have written all the inputs like E11, E22, E33. All these are the values of all these which will be provided in that input file, text file. Those values would be stored inside this array, UD array. UD of 8 will become that value, then UD of 9 will be a G12 value. Like that it will be stored, and so this is a user defined array, and it is actually a subset of a D array without U. D without U means UD without U, it becomes D. So D is an array which stores around 300 values. Okay, and out of those 300 values, UD has been allocated some values, and so user defined variables can store those can those user defined values can be stored in that array. So these values are stored there. So in this format you have to just follow, and can specify as many number of input variables you have basically. So if you look at a blank umat.in file, any of these all are same only. So you can go to this umat.i2. So this is a blank user defined input file, and you can modify it and include your input file. So they have provided I think around 20 input files, or I think 10 only. Yeah, 10. So 10 input files they have provided, and we can make use of these input files. So let us now check out where we are invoking this user input file also. If we go inside the again same user folder, we have element file. So this is the file element01.f, where our main code lies related to the plates and shell case. So this is the code, and let us look at just the piece where we are invoking those user inputs. Uh, yeah, you can see here it is being accessed through this D array. So there are around 450 parameters, 450 values stored in that, and out of that U parameters are given 149 entries. So if we subtract that, so we get the index of the user defined values. So if we just do uprm plus 6, we get this e11 value and e22 like that. So whatever values we have defined over there, all those are accessible over here, and then we have written our vam expressions. So all these values, these are all numerical values which will be substituted in these expressions. So these are the expressions which we obtained from Mathematica, and we are basically we have written them over here using Fortran form and Python patch file, and in this format we have directly written. So we did not write it manually everything, we just wrote a small script, Python based script, and converted those Mathematica expressions obtained from Fortran form, and then after applying the Python patch file, it was converted into this. So there's a special format which you have to follow. This maximum character should not exceed a length of 70 or 72, and there has to be a and over here. So like that format we have to follow. So all these expressions we have written. So this is the vam zeroth order subroutine. Okay, and it generates the C stress resultant constitutive matrix, and membrane stresses, bending stress, and shear stress is in the output. These are all in terms of the 2D in plane strains. So this is what we have done.